section 4.7. This is the last section in chapter 4. We're going to do inverse trig functions that will help us find an angle where an exact value occurs. We're going to start first and foremost with the graph of y equals sine of x. And again, this is something that we worked on the last couple of days. So have your unit circle in front of you. And because it's sine or cosine, we can just use values of pi over 2. We don't need all of the pi over 4 intervals. And sine goes from -1 to 1. Okay? So the sine of 0 is 0. The sine at pi over 2 is 1. The sine at pi is 0. The sine of 3 pi over 2 is -1. And the sine at 2 pi is 0. And I could keep going. Negative pi over 2 is -1. And you get this curve. Okay, and we're looking at the sine curve. Now, we talked before, the domain, if for this function is all reals, we can put in any positive or negative angle. The range, though, goes from -1 to 1. And in this section, we're talking about the inverses. And what we need to know is that the inverses switch domain and range. Now, the biggest thing, and I'm going to change the color here real quick, the biggest thing as we do this is we need to restrict what happens on the sine curve because it needs to pass the horizontal line test. And the horizontal line test will tell us if the inverse is a function. And we want the inverse sine to be a function, so we need to restrict this domain. And we always restrict right around 0. So what I'm going to look at is if I go from 0 to pi over 2, I could get part of my function, and I want to include both the maximum and a minimum point. But now if I continued on to pi, you'll notice that it won't pass this horizontal line test. So instead of going forward to pi, or 3 pi over 2 to get down to a minimum, I'm going to go backwards to negative pi over 2 so that I hit both that minimum point and a maximum point. And this restriction then will pass the horizontal line test. And so this part right here is what we're going to use to restrict in order to find the inverse sine. So I'm going to graph this one for us a second. And as I look at it, we need now our y values are going to become our x values. So we now go from -1 to +1 on our x's. And our y values then were the x values, and we go now from -pi over 2 to pi over 2. And so I'm going to plot these points in the other order. So this was like pi over 2, 1. Now the point's going to be 1 pi over 2. And then you have the point 0, 0, so I still have this point 0, 0. And you have the point -pi over 2, -1. So -1, -pi over 2. And this is then our inverse sine. So this is the graph for the inverse sine of x. And you notice we had to restrict it. And now if you look at this inverse sine function, it will pass both the HLT and the VLT, which is what we want to happen because we want to know that this is a function and its inverse, the regular sine graph, is also a function. Now if we look at domain and range, our domain now goes from -1 to 1, and our range goes from -pi over 2 to a +pi over 2. And so what we're going to do is we're going to have to restrict the domain. Now if I look at this in terms of the unit circle and quadrants, pi over 2 is up here, -pi over 2 is down here. So I'm looking in this section, which basically is quadrants 1 and quadrants 4. So when we try to find an inverse sine, we're going to get an angle between pi over 2 and -pi over 2. Now, your book doesn't just call it an inverse sine, it also calls it an arc sine. An arc sine or inverse sine is the angle at which you get an exact value. So we're going backwards. Instead of saying what is the sine of an angle, we're now saying find the angle. This is our goal for an inverse, is to find the angle that has a given exact value. So that's the idea of sine. We're going to do cosine and tangent. We're going to look at kind of all of these as we go through. So I'm going to slide down. We're going to do the same thing. I'm going to start by graphing the basic cosine. So let me put my basic cosine graph in there. Again, because it's cosine, we can use pi over 2's instead of the pi over 4 intervals. Pi over 4 we had to use for tangent, cotangent, secant, and cosecant. And we also know that it goes from -1 to 1. Now it might be a better idea too if you stop yourself and try and graph the cosine first and then come back with us. Because again, you're going to have to graph sine and cosines, well, any of the trig functions without your calculator. Okay, now cosine starts at 0. You have 1. Pi over 2 is 0. Pi is -1. 3 pi over 2 is 0. And 2 pi is 1. I could go back to negative pi over 2 and get 0. And let's see if we can curve this around. Okay. Our domain, we can have both positive and negative angles. So from negative infinity to infinity. And our range, again, is from -1 to 1. Now, I'm going to change colors again because our goal is to restrict this domain right around 0. So it has to include this. But I need to restrict it again so that I hit a maximum and a minimum while passing the HLT. So, well, if I go forward, we always want to try forward first. I get to 0. I don't want to go back because if I go back, I won't pass this HLT. So I'm going to keep going to get my minimum this way. And so now I've hit this minimum, I've hit this maximum, and this function right here passes the HLT. So this chunk right here is what we're looking at then for the inverse cosine. And again, you always start at 0 and you say, do I need to go forward to get to a minimum or do I need to go backwards to get to a minimum? And that's kind of what we're looking at. So if I start to graph the inverse, let me go up a little bit. This is negative pi over 2, and maybe we don't need that, but I'm going to put it in anyways. Because now my x values become my y values, so my angles are now my y values. And my exact values, -1 and 1, become my x values. Now this is the point 0, 1, and this is the point pi -1. So I'm going to flip those. At the point 1, 0, 1, 0, I can put on this graph. And then I have this point pi over 2, 0. So I'm going to go to 0 and then pi over 2. And instead of pi -1, I'm going to go to -1 and up pi. And so you'll see I have this graph. And so this is the graph here of the inverse cosine. So again, I'm going to look at the unit circle to say, well then how does that restrict my domain in terms of the unit circle? Well, let's I guess start domain and range before we start. Domain, you'll see I start at -1, I go to +1, and I include both of them because I have points there. And my range, you'll notice I start at 0 radians and I go up to pi radians. So from 0 to pi. If I look at that on my unit circle, here's 0, here's pi. So which quadrants am I restricting? I'm going to get answers in quadrants 1 and 2. And again, the goal of this is to be able to find the angle. Again, we're trying to find an angle at which the absolute value, or I'm sorry, not the absolute value, let's try again, at which the inverse cosine, at which we get an exact value. Let's put this in the best way we can. So we're trying to find the angle which gives us that exact value. Okay, so let's look at the ones right below. We're asking you, where's the inverse cosine or the arc cosine at 1? So they're saying, what is theta? What angle gives me a value, a cosine value of 1? Well, if I go to my unit circle, cosine is the x, so I have have this point, 1, 0, 0, 1, negative 1, 0. Where do I get the cosine value of 1? Well, my answer is 0, because again, I can only have an angle from 0 to pi. I don't want to say 2 pi because I'm not within that range. So let's go again. At what angle is the cosine going to be 0? At what angle do I look at the cosine being 0? The cosine is 0 at pi over 2. And the last one, what angle gives me the cosine of 1/2? Okay, well 1/2 is one of those other exact values. Cosine is the first number, so let's talk pattern. 3, 2, 1. So I'm looking at this third point, that's 1/2 square root of 3 over 2. What angle is this? Well, this is 60 degrees, but again, we want this in terms of radians, so our radian degree is pi over 3, or I guess 60 degrees, I would take either of those. So they're trying to figure out on your unit circle, which is why the unit circle is so important, what angle gives you a value of 1/2 for the x value or the cosine. And again, it comes down to the unit circle. The biggest thing, though, that you need to know is cosine is in quadrants 1 and 2, sine is in quadrants 1 and 4. And that's the big thing kind of going through, is figuring out, okay, where do I need to write my angle? In terms of the first and second quadrant, or in terms of the first and fourth quadrant? Okay, the next one we're looking at is the tangent graph. So let's talk in terms of the tangent graph. And the tangent, we said you should be using your pi over 4s. So I'm going to put the hash marks in for those pi over 4 lines. There's pi, 3 pi over 2, and 2 pi. And now if you want, we could look at a table, and if your table then says, okay, where do we have these undefined? Those are kind of the big things going through. So 0, pi over 4, pi over 2, and we did this table yesterday, so we want to kind of go through this rather quickly, but let's just start here and see if we can recognize a pattern. At 0, if I look at my unit circle, let's throw this unit circle up here. At 0, I have the point 1, 0. And tangent is sine over cosine. So sine over cosine, 0 over 1 is 0. Alright, at pi over 4, my exact values are exactly the same. So when you divide them, you get 1. At pi over 2, I get the point 0, 1. So sine divided by cosine is an undefined fraction. And at 3 pi over 4, one value is positive, one value is negative, so a positive divided by a negative is negative 1. And at pi, I have the point negative 1, 0, and 0 divided by anything is just 0. And I think we could start to see this pattern, and hopefully you kind of recognize it from the day before. But you can kind of see this pattern. So if I plot these points 0, 0, at pi over 4 you get 1, which means at negative pi over 4 you get negative 1, and you get this curve. At pi over 2 you have undefined. At pi you have 0, so 3 pi over 2 you have an undefined. At 2 pi you have 0. Let's see if I can quick draw this in. Again, this is something maybe you should be doing on your own and then checking with us when you're done. But you kind of get this graph. Okay, and again, we want to look at where we can restrict this. Because we want to restrict it, again, right around 0, but we want a restriction to pass both the VLT and the HLT. And as I look at it, I hit a minimum down here, I hit the maximum up here, and so we're going to keep this whole interval here. Now, we said yesterday the domain was all reals except we have an asymptote at pi over 2 plus pi n, because the next asymptote is a pi from that, and the next asymptote's a pi from that. my range is from negative infinity to infinity. So I'm going to take this one branch of my tangent, and I'm going to use that then for my inverse. So if I make these, my angles, instead of being at the x values, they're now going to be my y values. So negative pi over 2 and a positive pi over 2. And my y values of negative 1 to positive 1 now become my x values. And then I'm going to plot my points again. So this is the point 0, 0. Even if I look at switching the x and the y, it's still 0, 0. This is the point pi over 2, 1. I'm sorry, not pi over 2, pi over 4, 1. So I should probably put my pi over 4 tick marks in there. So at positive 1, I go up to a positive pi over 4. This point down here is negative pi over 4, negative 1. So I flip that negative 1, negative pi over 4. And the asymptotes actually, in this case, also need to be part of the inverse function. So at negative pi over 2, I now have this horizontal asymptote. And at positive pi over 2, I now have this horizontal asymptote. And as I look at my inverse tangent then, you'll see that it starts to run kind of along those asymptote lines. And so this is the inverse tangent. Now if I look at domain and range, domain, the arrows keep going to the left to tell me negative infinity. The arrow keeps going to the right, which tells me positive infinity. And my range is from negative pi over 2 to pi over 2, but we can't include those endpoints because I have asymptotes there. So what that says in terms of the unit circle is I'm still looking for angles between quadrants 1 and 4. So there's 4 and 1. The problem is, though, I cannot have this negative pi over 2 be an angle because I get an undefined fraction. And I can't have this pi over 2 be an angle because, again, I get an undefined fraction. So they're asking you in this case, again, what angle gets you the exact value. Gets you the exact value. Okay? Now the biggest thing, you need to know the restrictions on these three inverse tangents. My suggestion to you is also try and take the inverse of secant, cosecant, and cotangent. That's not something we do together, but it would be something good to practice. But again, you need to look at the restrictions right around the 0 degree or 0 radian mark as you go through. Let me slide down to our last part on compositions of functions. All right, as we look at composition functions, we're going to talk about taking basically an inverse with a regular trig function. Sometimes they're going to match, sometimes they don't. I want to start with the idea that what happens if they match. And we're looking always at this inside function. And what you notice is the sine and an inverse sine will cancel out because they're inverses, and you're left with x. Now you want, because the arc sine is in with the x, you want this arc sine, whatever that x is, to be in the domain of the arc sine. Okay? Where if the arc sine's on the outside, they still do cancel, but we want this value of y, if it's an answer, to be in the range of the arc sine. And so you look at basically, is it in the inside or is it in the outside? If it's in the inside, you're inputting it, so it's the domain portion. If it's on the outside, you're going to get the output, which means it's the range. In this case, the domain of an arc sine, x, would have to be between negative 1 and 1, because the domain of an arc sine is between negative 1 and 1. Where if you look at the range of an arc sine has to be in quadrants 1 and 4, so negative pi over 2 to pi over 2. And if y is not within that range, then you can't get an answer. Same thing again, this arc cosine is on the inside, so we're talking about the domain. In order for these two to cross out and get a value of x, the domain for the arc cosine has to be between negative 1 and 1. In this case, again, because the arc cosine is on the outside, we're looking at the range. So the y value here has to be within the range of the arc cosine in order to cancel these out. And the range of the arc cosine is in quadrants 1 and 2, so between 0 and pi. And I'm going to show you kind of how this relates to some of the ones below, but I just want to give you this idea. Again, the arctangent here is inside, so we're talking about the domain. When these cancel out, if I'm going to get a value of x has to be in the domain of an arctangent. The domain of the arctangent was between negative infinity and infinity. And finally, if the arctangent's in the outside, we're looking at the range. So if these were to cancel, y would have to be in the range, and the range for the arctangent is between negative pi over 2 and pi over 2. This one obviously not including, where the ones above did include. Okay, so here's what it means. Okay, arctangent, if you look on the inside, we're talking about the domain. The domain of an arctangent is between negative infinity and infinity. Because 13 is in that domain of negative infinity to infinity, my answer then is 13. In the second one, the arc cosine, or the inverse cosine, is on the inside, so we're talking about the domain of the cosine. Okay, in this case, the domain of the cosine is between negative 1 and 1. Is pi over 2 in that domain? And the answer is no, because our domain is an exact value. This is a degree or a radian measure. It's an angle. So this is not possible. Okay, you cannot take this and evaluate this because the pi over 2 is not in the domain of an inverse cosine. Okay, so let's go here. The inverse sine, we're looking because it's on the outside for the range. The range of an inverse cosine is between negative pi over 2 and pi over 2, including. Okay? Now the problem is, you'll notice this is a positive angle and then it goes to negative angles in the fourth quadrant. 7 pi over 4 is not written the way we need it to be written. It is in the fourth quadrant, which is good because our range covers the fourth quadrant. But in order for us to answer this, we need to take this angle and put the angle in the fourth quadrant. Well, if I look at a unit circle, 7 pi over 4 is right here. So what is it in terms of the negative angle? This is negative pi over 4. And now because it's written in the correct form, I can cancel these out. My angle is negative pi over 4. You cannot tell me it's 7 pi over 4, or you won't actually have this written correctly. Okay, so be careful there. I'm going to go to the last section where we want to find the exact value. And in this case, we're going to have to draw some triangles. This says find the angle where the cosine is 1/3. This part right here is going to ask me to draw a triangle. So I'm going to draw a triangle, and I'm going to put my angle in. Cosine is the adjacent over the hypotenuse. Once I draw that triangle, you can forget about this now. What it says now is, can you find the tangent for this triangle? Well, tangent is opposite over adjacent. The problem is I don't know this opposite side, so now I need to find that using Pythagorean theorem. So x squared plus 1 squared equals 3 squared. When I subtract 1, x squared is 8, and I square root it to get that x is 2 square roots of 2. So this value here is 2 square roots of 2. So when I now do the tangent, 2 square roots of 2 divided by 1, my answer then is 2 square roots of 2. And so when the trig values do not match, it means make a triangle. Okay, and we're going to use that triangle. So let me show you one more, and we'll practice some in class. This inverse sine is opposite over hypotenuse, so I'm going to write it as a fraction.
Welch, please come to the switchboard. Dalton Welch, please come to the switchboard.
I apologize for that. If I look at my angle, opposite over hypotenuse. So my opposite is 3x, my hypotenuse is 1. Once I've made my triangle, cross this off. I want to know what's the cosine for this triangle. Well, again, I need to know this value, so I'm going to use Pythagorean theorem. And I'm going to call this A, something like that. I don't want to use x because x is already there. So I'm going to do this. 1 squared equals 3x squared plus a squared. So 1 equals 9x squared plus a squared. And when I subtract 9x squared, 1 minus 9x squared equals a squared, and I square root. So the value of this adjacent side, if I get rid of this, is the square root of 1 minus 9x squared. And if I'm looking for the cosine, cosine is adjacent over hypotenuse, so I just get an answer of 1 minus 9x squared, and you take the square root of that. And so the whole goal of this, if the trig values do not match, then you want to make triangles. If they match, like they did above, then you want to talk about whether you're looking for domain and range, and is the value that they give you acceptable. That's section 4.7. We're going to talk about this more in class, but again, take a second, try the homework, see if there's things that you can do, especially these questions like 4 and 5 that are a little bit more difficult. You also want to make sure you can graph all 6 inverse functions before we get to the task.